Elizabeth White. Today we will talk about hypothesis testing for two samples. So we can also call it inferences from two samples, and we will go over some traditional methods and primarily use the TI-84 to do the calculations with the p-value method. Now the first one is if I want to do the hypothesis testing using two proportions. There are a couple of things I need to remember. I need to make sure that NP is greater or equal to 5, NQ is greater than or equal to 5 to be able to use all these formulas. And these are my sample results, number of successes over N1, and P2 is the other sample, and number of successes in the second sample over N2. Then I can also calculate p-hat, and when you put everything in a test statistic formula, it is pretty long and it may take some time to do that. So let's do an example and find out how I can do this with a shortcut using a TI-84. Now, the example that I will use is I'm going to use the 0.05 significant level, and I want to test the claim that the proportion of black drivers stopped by the police is greater than the proportion of white drivers who are stopped. So I would like to set my hypothesis as H null, that there is no difference between first and second sample. And H1 is, this is African American drivers proportion that are stopped are greater than P2, which are the white drivers. So I have gathered all that information from something, let's say from a study, and there are 200 drivers in this one, 1,400 in that one, 24 of them are stopped versus 147 of them stopped. So let's go look at it. Now, this may look very big compared to this one, but the problem is the starting sample sizes are different sizes. That's why it looks like that. So, I have that data. Now I'm going to go and do the analysis. Now let's look at the formulas first. If I were to do it by hand, I just am displaying this so that you can do your calculations by hand. You can calculate the p-hat, putting in all these numbers, and get the q-hat by subtracting, and then these are given and plug that into z and you get 0.64. Since my hypothesis is set the way that it is, I'm doing a right tail test. You can also go and compare this to 0.05 if you are calculating the p-value. Or you can go and compare the test statistic of 0.64 to your critical z, 1.6, and you'll end up at 0.64 here versus 1.6, which is here. That means you're outside the critical region. So let's see if we can conclude the same thing using our calculator. So I have to go and enter all this data. Let's go to the calculator. When I want to do this using my calculator, I need to pick the stat button, and I need to pick 2-prop-z test under the tests. So if you go down here, you will be seeing it, 2-prop-z test. Now you will be entering that x1, and I'll just go back to that one. My sample 1 is going to be 24, and N1 is 200 drivers, and my X2 is going to be 147 out of 1,400 drivers. And now I look at my claim, H1, it says P1 greater than P2. So I need to pick this one, greater than P2, and all I have to do is go to calculate. Now when I go to calculate, I compare this to my paper. I will be seeing z of 0.64 as you see, 0.64. But what's important is, from the p-value method, I will compare the p-value to my alpha. And my p-value is 0.26, and 0.26 is bigger than 0.05. I know I'm outside the critical region. Now let's go do another example. Let's say I want to find, in the same kind of setup, I want to find the interval for the differences in proportions. For that one, for using the same example, once you use your calculator, it will stay in there. Now, if I want to get the 2-prop z interval, I need to go and I need to get stat, and you are going to go to test. Now I'm looking for the differences, the interval for the differences of proportions. For that one, I need to go and I need to pick 2-prop z interval, and that is going to be choice 6. When you pick that one, the data that I entered previously will still be there if you just did this right after your hypothesis testing. x1 24, n1 200, x2 147, n2 1400, and your hypothesis is already there. Then you can go and pick calculate. When you pick calculate, you have the 2-prop z test. Now I want to go to get the interval. You go to stat, test, 2-prop z interval this time. I push that. Let's go to 2-prop z interval. You have to pick the B option. And all your data will be in there. All you have to enter is your confidence level, and 0.05. You subtract that from 1, you'll get 0.95, and you simply calculate. When you calculate, you get your interval. It goes from negative 0.03 to 0.06. And that actually tells you that it does cross over 0, and that means that is in accordance with your first conclusion that you did with your hypothesis testing. So I do not reject H now. So I did find the hypothesis testing and the interval for the differences of proportions. Let's do the same kind of thing, same kind of analysis for 2 means independent samples, as long as they are both large and both samples come from populations having normal distributions. If you were to do that, you would have used the t-test, and it has a pretty big formula. Now let's assume I have this case. This table concludes the distances of the home runs hit in record-setting seasons by McGwire and Barry Bonds. I'm going to use a 0.05 significance level to test the claim that the distances come from populations with different means. So I'm looking at the different means. So I have to set up my hypothesis. Mu1 equals mu2, that means they are the same. And different means that the claim is assuming that they are different. And my alpha is 0.05. So when I enter this in my calculator, this is doing it by hand, comparing the t to my t critical, and I actually get 2.273, and I need to compare that to 1994, and it looks like I'm inside the critical region. I end up rejecting H null. But what do I do when I do it with my TI-84? So let's go to the calculator. Let me clear this screen. Now I'm going to go and do the test, stat, test again, but this time I will do 2-sample t-test. When you go 2-sample t-test, it's option 4. You pick that up. Now you can also enter the data or statistics. I will enter the statistics, so I have to go back and get those numbers. The first one is going to be McGwire, so that's going to be 418.5. SX1 is going to be 45.5. and n equals 70. That's given. The second one is Berry bonds, and then I will get the x bar 403.7, and the Sx in this case is going to be 30.6, and I'm looking at 73 hits. Now I have to pick my claim. Are they equal? Are they not equal? The first one is the one that I want. Now in this case, I will assume they are not pooled, and you can do this with the F-test, determine whether or not it's pooled or not pooled. But at this point, I'm not going to go into it. Assume it's not pooled right now, and then go down, and you will calculate it. And it will give you the values that we ended up with before. If you look at the paper, 2.273 for T, and in addition, it will give us the p-value. The p-value ends up being 0.02, and it is less than 0.05. That means you are in the critical region, and you end up rejecting H null. Now let's go do another example. Actually, I will do the same example, but this time I will assume I want to find out the difference of the means. And if you were to do it by hand, you would have used the formula for E and all these things, but I'm going to go and use the same kind of formula, but this time I will do the steps in your calculator. So let's go to the calculator. I will go to Stat and Test. Now, instead of picking anything else, I will go to 2 sample T interval, and that one is, these are the test ones, Z interval, T interval. Here we go, 2 sample T interval. You pick that one. And if you're doing this right after what you did before, your data will be entered. And for 18.5, 45.5, 70, and you did enter that before. 43.7, 30.6, and 73. And the only thing you need to enter is pretty much sea level. It's all in there, no pooled, and you just have to calculate. When you calculate it, you will actually see that your mean goes from 1.9 to 27.7, which is what I calculated by hand, and it's not crossing over. It's not containing the 0. That means you reject H null. Now, what do you do when you have matched pairs and you want to look at the mean value of differences? If you want to do that, you use the statistic T, and you do your statistics on the difference. Okay, so let me show you what that means. Let's assume I have a case like this. I have 5 actual low temperatures and the corresponding low temperatures that were predicted 5 days earlier. So this is the actual, this is the forecast. So if you were to do this by hand, what you need to do, you need to enter the actual, you need to enter the forecast, and then calculate the D. You can't let your calculator do that. And then you have to do the t-test on the differences. So let's do that in the calculator. So I'm going to go and show you how you enter the data and actually use the data instead of the statistics to do the problem. So to do that, I go to Stat, Edit. In the first column, I'm going to enter the actual low temperatures, which is 1, -5, -5 again, and 23, and 9. If you go to L2, these are the forecasts: 16, 16, 20, 22, and 15. What I will enter in L3 is L1 minus L2. To be able to do that, I go to L3, push Enter. Then I push L1 minus L2, and that should display the differences: negative 15, negative 21, negative 25, 1, and negative 6. Now let's go back to the table. Now what I do is I have to just tell them that I'm doing this, the stat test t-test on L3, which is the differences. So what I need to do is I need to tell the calculator, without doing all these t-statistic area, and I had concluded that if I did it by hand, I end up with the outside the critical region, because t turns out to be negative 2.7, and you're comparing it to negative 2776 versus 276. It's very close. So you end up not rejecting H null. So let's do the statistics using our calculator. So I'm going to go to Stat, and you're going to go to Test, and I will do the t-test. This is a little bit different than before. I used to enter the stats. Now I'm going to enter the data. Now if you look in there, I push enter, and it just tells me what's your mu. Now that one, I have to go and enter the mean value, which happens to be negative 13.2, and I have to tell them where I'm doing that. That has to be done in L3. Let's go get that one. All right, and I'm looking at whether or not they are the same or not. So I have to pick that one. But let me go back to this mu null. If I enter this negative, this is my d hat. This is not what I enter in there. I have to look at the 0. That's where the differences are, whether 0 or not. So I have to enter 0 in here. So I have to enter the mu d equals 0, because I'm doing the statistics on the differences. So you want to find out whether or not they are the same, or the difference is going to be 0 if they are the same. So I enter 0, L3, and 1, and not equal. When you go down, you pick calculate, and you will actually get your t, which is negative 2.76. If you go back to the paper, t of negative 276. The other thing that you see from your calculator is p of 0.0507. It's pretty close, but it is going to be a little bit bigger than 0.05. So you end up with the same conclusion by comparing the p-values. Now if I'm looking at finding the interval for the differences in the means, what I can do, I can use the same data. I don't have to re-enter it. And you just put the d's, and in this case I put them in L3, and I will do the t interval instead of doing the t statistics. So let's go to the calculator. I will go to Stat, and I will go to Test. Now I'm looking for the interval. In this case I'm not going to go to t-test, but I have to go to t-interval instead. And that's option 8. So if you push enter, I know that I need to enter the data, so I say data in L3, and all I have to do is just enter the confidence level, which is 0.95, and I say calculate, and that will give you the interval. It goes from negative 26.47 to 0.0858. I might have, let's go back to this one. Let me calculate this. If I entered these right, I got negative 26.47 to 0.06897. And this contains 0. That means I do not reject H null. So this concludes this section. on hypothesis testing using 2 sample sets. So I'll see you next time when we do another module together.